Hey, what's up YouTube? Welcome to another Moralis blueprint. This week we are going to create a Binance trading bot. This project is going to have 3 steps. First, we are going to create all the tools we are going to need to connect to the Binance API with all the functions to get the information from candles, query the assets, create a trade, cancel it, query the open trades, and a lot more. On the second part, we are going to start applying some trading strategies, such as the average strategy or the candlestick increment or decrement. We are going to code these strategies extensively, and we are going to connect our bot to Moralis APIs. And at the end, we are going to automate the trading process to make the trade work for us even if we are sleeping. And this is going to be based by what the whales or traders you trust does. So at the end, we can leave our Python server running for us, and the bot is going to automatically get the information of the trades made by the whale and make the analysis. If the analysis gets completed successfully, it's going to execute a trade in our behalf. This is going to be a really complete blueprint with a lot of features, so keep watching because we are just getting started. What's up YouTube, my name is Vasily, your Web3 instructor from Latin America, Ecuador. I've been building on the space since 2020 with cool crypto projects. In my free time I really enjoy singing and playing the guitar, and if the time is good, I like to go out and take some meditations. But enough about me, let's go back to the video and start building. So, a trading bot using the Binance API and connected to the Moralis endpoints. For this Moralis blueprint, we are going to have 3 simple steps. First of all, create the basic functionality. This is going to allow us to connect to the Binance API and create the basic functions we are going to be constantly using to interact with the Binance API to get the information from the candlesticks, for example, get the pairs of symbols which are available for trading, put an order, cancel an order, and etc. etc. Then we are going to create a trading strategy to apply those functions and decide if we should buy or sell a given pair of tokens. And finally, we are going to automate the trading process. For that, we are going to, of course, be using Moralis endpoints. So let's get started with step 1, create the basic functionality. Okay, let's get started by getting access to the Binance API. This is the API we are going to need in order to execute all the orders and the interaction with Binance. So I have here a new file called settings.json on which I have these Binance keys with the API key and the secret key. I also added the addresses for the tokens we are going to be working on this project, BUSD, Ethereum, and Binance Bitcoin. So in order for you to get the Binance API keys, you can go to your Binance account and get them for the official mainnet. However, as we want to test this out, and this is a demo project for you, we are going to use the testnet. Getting access to the spot testnet is really easy. We just have to go to the official Binance page, select spot testnet. We are going to need to log in with our GitHub account, and once we get access, we are going to have this panel over here on which we can generate new API keys. I'm going to paste the ones I already generated on my settings file. Remember, these API keys are sensitive information. You must not share this information with anyone. I'm showing this because it's a demo project and I'm going to delete these keys after the video. And also, these are demo just for testnet, but if you're going to use this bot on the mainnet, be sure you are not sharing these API keys with anyone. So let's continue. Now here we have a different script called Binance.py. In this script, we are going to determine all the functions we are going to use to interact with the Binance API. And for that, we need to use a Python library called Binance Connector Python, which you can find on its official GitHub page. Remember, all of these references are going to be on the video description. So let's copy the installation command and paste it on our console. Let's click enter. I already have it, so the installation is going to be instant for me. And once we have it, we can start using Binance functions. So let's return to the project code and start adding some functionalities. First of all, we need to import binance.spot from spot. And I'm also going to import pandas. Pandas is a really popular library for Python, mostly used for machine learning and data analytics, and we are going to use some pandas capabilities on this demo to have a better data frames when we get the information from Binance. But for now, let's keep it simple. So first we need to know if we can actually connect to the Binance API. So I'm going to create a function to get the status. So def query Binance status. The status is going to be the spot, which was imported from the Binance library, dot system status. And if we have an status, and the status is 0, we are going to return true. Else, let's raise a connection error. This means we are not being able to connect to Binance. Now, once we know that we are able to connect to the Binance API, let's also have a function to get the account we are using. So, function query account. This is going to use an API key, which is the one we just set up on the project settings, and the secret key, which is also on the project settings. We are going to return again spot, which is the Binance library which was installed, and we are going to use the API key, going to be equal to the API key, the API secret, going to be equal to the API secret, and we need to define a base URL. By default, if we don't define this base URL, the Binance library is going to use the Binance mainnet, but as we are using testing accounts on this, we can define the base URL to the Binance testnet, so testnet.binance.vision. And of course, we need to get the account from this, so dot account. Finally, let's also test if the testnet is working properly. So query testnet. So I'm going to have a client is going to be equal to a spot. Again, we are going to use the same base URL, and we are just going to print the client.time. And with these three simple functions, we can ensure we are connecting to the Binance API for spot trading, and also be ensured that we are using the correct account. So let's test this out. Let's save this. Here I have another Python script called main.py, on which we can use those functions. So first, let's do some basic imports. Import JSON, we are going to use this later. Import OS, we are going to also use this later. And let's import Binance, which is all the script we have here with all of these functions. We need to get the information from the settings. So import path going to be equal to the settings.json. So for example, in the Binance.py, we have the query account, which is going to use the API key and the secret key. And we are going to be using all of these on almost all the functions we are going to use. So we need to retrieve the information from this setting.json. So on the main.py, I'm going to create a function to import the settings. So import settings. This import settings is going to take an import path, which we just declared over here. First, we are going to ensure that the path exists. If os.path.exists, we are going to import that path. Let's open the path. So file equals open import path as read, project settings equal json.load file, and then close that file. Finally, we are going to return the project settings. If the path does not exist, let's just say return import error, in case we forget to add this settings.json, or if the path we are declaring here is different. For example, maybe we have another folder and we accidentally put settings.json into that folder. Now let's create the entry point for our application. So if name equals main, let's first import the project settings. So project settings is going to be equal to the function we just created using that import path. Now let's declare both the API key and the secret key. So API key is going to be equal to project settings. Is not the API key, but actually is on Binance keys. And we want the API key. The same goes for the secret key. So secret key, use the project settings and the secret key. Now let's retrieve the account information and let's see if we are being able to connect. So account equals Binance.query account, sending over the API key and the secret key. Let's print that account and test the other functions, such as query the testnet. Let's query the Binance status. So status is going to be equal to Binance.query Binance status. Let's print that status. And also let's query the testnet. So testnet is going to be again Binance.query testnet. Now we are ready to test this Python script on our terminal. Let's try and execute this with python main.py, and we have an error here, and the reason is because we are importing here on Binance.py the Binance library. But due how to Python works, we have a library and a file with the same name is going to have conflicts with this. So let's just refactor this, and instead of just Binance.py, let's say Binance Connect. Let's click on OK. And if we go back to main.py, we have this Binance Connect replaced in all the code. So we can try and test this out again. So let's go here, clear the console and run python main.py. And as you can see here, we have information for the code, including the balance we have for each token available on the testnet. And the important part we care here is can trade parameter, which means this account is available for trading. Also, we have true, which, as you already know, represents the status of the connection with Binance, which in this case is true. And here we are querying the testnet, and the response of the console is the server time and the time into a Unix timestamp. So as you can see here, we now are successfully connecting to Binance. Now, of course, we don't want just to connect to Binance. We want to be able to execute trades, get the information from the candlesticks, query the asset lists, get the open trades, be able to cancel the trades, and so on. So let's add those into Binance Connect. First of all, let's create a function to get the information of the candlesticks. It means the information of the average of the price of any candle for given asset, the open price, the close price, and all those things. So let's say function to query candlestick data. So def get candlestick data. We are going to send over the symbol we want to look for, the time frame. Remember, all the trading platforms such as Binance work with time frames such as 1 minute, 1 hour, 1 day, and etc. And also the QTY, which stands for the number of candles we want to retrieve for a given asset. Let's get the data. So get raw data is going to be equal to spot.klines, and let's send over the symbol, the interval, and the limit. Again, if you don't know how this function works, remember you can always check over the documentation on the Binance docs. We click over here and open this on the browser. We find that this keylines parameter gives us the information of the candlestick, including the open price, the high price, the low price, the close price, the volume, and more parameters. And we want to get that information for each symbol we send over to get candlestick data here on our Python script. Now let's return this data. So let's say converted data. Let's set up an empty array for now. And now let's append all the information we are going to get from this for each candle. So for candle in raw data, let's say converted candle going to be equal a dictionary, and here we are going to get that information. So for example, the time is going to be equal to candle 0, the open price is going to be candle 1, but we want to use numbers here, so let's transform this into a float. And the same is going to be for the rest of the parameters, such as the high, the low, the close, the volume, and all of those we just saw on the official Binance documentation. And again, if you don't know which values does the K-lines function returns, don't forget to go to the Binance docs and check them out over here. Basically, I'm just creating one parameter for each one of these return values. And I'm creating a new item on the array for each candle we are retrieving based on this QTY parameter over here. Let's add the data. So converted data dot append the converted candle, and once we end up with this, of course we have to add this inside of the for loop, and outside it we can just return that converted data. And as easy as that, we have now the ability to get the information of the values of any amount of candles for a specific asset. So let's test this out. For example, let's go back to the main.py. I'm going to just delete all of this, and I'm going to say candles is going to be equal to Binance connect.get candlestick data. And here we are going to send the parameters we need. We need the symbol, the time frame, and the number of candles. So let's do that. Let's use the symbol as ETH_BTC for, let's say, 1 hour, and let's get just the last 3 candles. Let's save this and then print those candles. Let's go back to the terminal and test this out. So I'm going to clear my terminal and run again the mine script. And as you can see here, we get the information of the last 3 candlesticks for the pair Ethereum Bitcoin. We are going to use this information later on the video to create a strategy to start trading with these assets. Now we need a function to get all the information of the possible pairs an asset could have. For example, if we input Binance USD, this function should return us all the pairs that token has for the network, in this case the test network. So let's go back to Binance Connect and create that function over here. So function to query all symbols from a base asset. Let's say here query quote asset list. Let's send over as parameter the quote assets symbol. Again, this function is going to take all the pairs available given a specific token. For example, if we put here Ethereum, is going to return us the Ethereum Bitcoin pair, the Ethereum BUSD pair, and etc, etc. So let's say symbol dictionary going to be equal to spot from the Binance library dot exchange info. This exchange info is going to take all the information of the pairs. Again, if you don't know what this function returns, put the cursor into it and you can always check the official Binance documentation. Let's convert this into a data frame. On this part of the video, we are going to use the pandas library. You can install it with pip install pandas. Don't forget to do that before continuing. And let's say symbol data frame is going to be equals to pandas.dataframe and send over the symbol dictionary and get all the symbols we can get. Now we need to track all the symbols with the base asset pair. So for example, if we send over Ethereum, we are going to get all the pairs which contains Ethereum. So quote symbol data frame is going to be equal to symbol dataframe.log and get the quote asset over here, which is going to be equal to the quote asset symbol. In this case, Ethereum on BUSD or whatever we want. Also, we need the symbols which are available for trading. So quote symbol data frame is going to be equal to quote symbol data frame. We are using the information we just create and just get the ones which has the trading capabilities. For example, we can have another pair. I'm going to say, for example, Ethereum and another we're talking like, I don't know, Shiba. And maybe the exchange, or in this case, Binance doesn't have this pair available for trading. So that's why we need the ones which actually has the capabilities to be traded. And let's return this data. Return quote symbol data frame. Let's test this out using that function and send it over Bitcoin, for example. Let's go back to the terminal and we get all the pairs available to be traded with Bitcoin and the Bitcoin pair. And this is going to be a pandas data frame. And now you might be thinking, okay, this part of the video is kind of tedious, but remember we are building the skeleton with all the functions we are going to use in order to be able to interact with the Python API and get the information of candles, get the ones available for trading, put an order, cancel an order, etc., etc. Once we have this skeleton, we are going to be able to create a new strategy, use that strategy, and experiment trading different assets. So for the next functions, I'm going to go a little bit faster because the principle is again the same. For example, we are going to need another function to create a new trade. So function to make trade with params. So make trade with params. This is going to take just the params and the project settings. Remember, on the project settings, we have all the information for the API key and the secret key. Let's say print making trade with params, set the API key. So API key is going to be equal to project settings Binance API key. The same is going to be for the secret key. Let's create the client. Create client. Client is going to be equal to spot, and we are going to send this information. API key, secret key, and the base URL. Again, we are going to use the base URL because we are using the testnet. If you omit this step, you are going to be trading directly on the Binance mainnet. So be aware that this is a potential risk, but also remember that the API keys we just set up on setis.json is going to be useful just for the testnet. If you want to use this Binance bot in production, put here your official Binance keys and remember not to share those with anyone. Once we have the client with the base information, we can say make the trade. Let's try to have a response. This is going to be equal to client new order with the params, return the response. And if everything goes wrong, let's say except connection refused, for example, as error, and print the error. Let's create another function to query the open trades. So get the information all the trades this account has. So function to query trades. Again, we need to define a new function, query open trades. We are going to send over the same information, the API key, the secret key, create a new client for the testnet. And here we can just say get trades, try, response equals client dot get open orders, return the response. And if everything goes wrong, for example, again, a connection error, let's print that error. As you can see here, this process is kind of repetitive. The only thing we are changing is the order. Here we are using the new order function, and here we are using the get open orders. Remember, if you don't know what this function returns, don't forget to check out the Binance documentation. You can access directly from the code. Now let's create a function to cancel the trade. So the process is going to be exactly the same. I'm going to just copy paste this part. declare the function, cancel order by symbol, declare the API key, the secret key, the client, and then use that client to cancel the trade. So cancel trade response, cancel open orders, and send over the symbol we want to cancel. Now, these are the functions we are going to use on this demo, but as I want to give you this project as a template, as a skeleton for you to be able to implement your own strategies, I'm going to add more complex functions that we are not going to use on today's demo, but you can 100% use on your future projects or future Binance bots. For example, let's add here a function to place a limit order for a sample. If you are not deep into trading and you don't understand what a limit order is or what a take profit order is, don't worry. Again, we are not going to use those functions on this demo, but you can then take those from the code repo and use them as reference. So for time's sake, I'm just going to put directly that function over here. Remember, the base part is always the same, declaring the API key, the secret key, and the client, and then we are going to have a new order, which is going to have the type of limit. The site, this is going to be for buying or selling, the symbol, the time in force, this is a technical parameter. I'm not going to explain now because this video will be too long. The quantity is the amount we want to trade and the price on which we want to execute that order. Let's create another function to have a stop loss order. This is going to be again the same. So let's put that function over here, place a stop loss order, sending over kind of the same information. And on the new order parameters, we are going to send this information over here. Let's add another function to have a take profit order. This order is going to automatically close once we reach a certain point of revenue. And this is it. With this, we have all the functions we might need to have at least a really basic Python trading bot. Again, we are not going to use the functions from this place limit order, but you can use them as reference if you are going to clone the code repo and start testing your own strategies. Now we are ready to go to the step 2 of this blueprint. Now we have the basic functionality for our bot, so now we can create a trading strategy. However, I have to give you a warning. This is not an investment advice. Remember, all the strategies you might want to add to your Binance bot should be back-tested, and you have to also add your own customized functionalities. For this demo, we are going to just create a demo strategy which is going to use some of the most popular indicators to decide if we have to buy or sell a given pair of tokens. But again, this is not an investment advice, and we cannot ensure that this strategy I'm going to show you here is going to be profitable on the long term. And again, use this just as a reference. So first thing first, as we already are getting the information of the candlesticks as just an array of elements with information of the closing, open, and other prices for each candlestick, let's transform that candlestick information into a pandas data frame we can then use to implement our strategies. So the first thing we are going to do for our strategy is create a function to convert the data from Binance candlesticks into a data frame. So let's say here def get and transform data. This is going to take a symbol we want to get the information from, the time frame, the number and the number of candles. Almost the same as we did for the function called query get candlesticks data, which you already know, gets all this information using the key lines functionality. So I'm going to say again, the raw data is going to be equal to the Binance Connect to get candlestick data, sending over the sample, the time frame, and the number of candles. And then let's transform this into a pandas data frame. So data frame is going to be equal to pandas data frame using that raw data. Now we need to transform some of the parameters we get in order for us to use compatible formats. So the time is going to be equal to pandas to date time and use milliseconds instead of the Unix timestamp. The same is going to go for the clones time. We are just transforming this into a pandas date time using milliseconds. And now we need to decide if the candle is green or red. Green is for the candlesticks on which the closing price is superior than the open price, and the red candles are the ones which the closing price is lower than the open price. So let's say here, df red or green is going to be equal to the numpy.where the data frame open is less than the data frame close. In this case, for each candle, it means, again, the candle is going to be green, otherwise it's going to be red. And finally, once we have this data converted, we can just say return the data frame, and return the df. Now, let's understand which is the first strategy we are going to apply on this strategy.py. Here we have the average strategy. We are going to compare two pairs using the same base asset, in this case Ethereum against Bitcoin, which is going to be the current valuation or the current ratio we want to calculate, and a reference ratio, which is going to be BUSD between Bitcoin. We are going to compare the current ratio against the reference ratio. If the current ratio is higher, it means that Bitcoin is overvalued relative to Ether, so it's a good idea selling it for Bitcoin. If the current ratio is lower than the reference, it means that Ethereum is undervalued, so we might consider buying Ethereum using Bitcoin. For applying this strategy, we can just take the information of the current market price using the information from the candlesticks. But the problem is, as you can see, that information comes really into a bad articulated form. So let's use an easier way. On this point, we are going to start using the Moralis APIs. So as you can see here, I have here another folder called Moralis with an empty script called app.py, and here we are going to create a simple Flask server which is going to connect to the Moralis endpoints. And talking about that, if you don't have a Moralis account yet, this is the part of the video for you to hit pause, go to moralis.io, create your free account, and here on your admin panel you are going to have access to your free API key, which we are going to be using. This API key is really good for testing purposes, small projects, or simple petitions. But if you're working with a big NFT collection or marketplace, step up your blockchain game with Moralis Pro. With twice the computing power and more requests, you can handle even the most demanding projects. Plus, enjoy unlimited daily records on your streams with automatic retries for a seamless experience. And with more replays and longer retention for your historic streams, you'll never miss a beat. Don't settle for basic, upgrade to Moralis Pro today and take your projects to the next level. On this opportunity, we are going to be using the token API to get the ERC20 token price for a given exchange. We can always check the endpoint to see which information we need. In this case, we need to provide the token address, the chain we want to use. We are using the Binance Smart Chain, but in this case, as we are testing this, is going to be the testnet. We need to select an exchange. On this case, we are going to use PancakeSwap, and we can also get the historical information based on block numbers, but again, we just want to have the current market price. So first of all, if you don't have Moralis installed on your Python instance, go to your terminal and use pip install Moralis. Also, as we are going to be using Flask, let's also import that. Pip install Flask. And also let's install python.env to get the information of the API key from a .env file and not adding that directly to our code. Once we have all the dependencies installed, we can continue. Let's add here some basic imports, such as Flask, Moralis, the .env file, and the date time. Let's also import OS and local. First, we are going to execute that load.env. That load.env, it's going to load the information of the environment variables. So on the root folder project, I'm going to create a new .env file. Here we are going to set up the Moralis API key. Again, remember this is sensitive information. Please do not share this Moralis key with anyone. I'm going to go back to my admin panel, copy mine, go back to the code and paste it over here. Save this and we can go back to the Flask server. So I'm going to declare that API key, getting the os.getEnv. Let's create a new Flask server, also using the local format, in our case UFT8. And let's create now a new endpoint to get that price. So first of all, let's create a root, and inside of this root we are going to have a new function called getPrices. For now, let's pass, and let's go back to the Moralis documentation to understand which information we need to add. So as you can see here, using Moralis APIs is really simple because we are going to be able to get the information with just a small portion of code. So I'm going to copy the reference code over here, go back to my project and paste that over here. Of course, we don't want to have this burned information over here, but instead send the information of the token we want to use and the chain each time we call this getPrices endpoint. So I'm going to say the chain and the address is going to be equal to request.ars.get and its respective name. The address is going to be now the address. The exchange, we are going to keep it as PancakeSwap, and the chain is going to be the chain we are going to send as parameter. So instead of just printing the information, we are going to return that result. And as easy as that, we have the endpoint we need to interact with the Moralis API. So now, as we want to run this as a server, let's add an entry point with app.run, and let's run this on the port 5002. And setting up the book as true, it means that each time we make changes into this server, is going to automatically reload. And with just 35 lines of code, we have a functional server on which we can connect to the Moralis endpoint. So let's test this out, shall we? So let's run the server with Python app.py. This is going to run the server on the desired port. So I'm going to just copy this and open Postman. So if I put that information into Postman, sending over the server IP address, the endpoint we already know is getPrice, and sending over the information, in this case the change is going to be the Binance change and the address is the address for Ethereum on the Binance change, we are going to have a response like this one, on which we are going to have the current price for Ethereum over here. So this endpoint is working properly. So now that we are capable to get the information of the current price of a given asset, we can implement this average strategy into our code. Let's go back to the strategy.py. Let's create a function, get the token price first. So let's say def get token price, on which we are going to send the address and the chain. Here we are going to make an API call to get the price. So the URL is going to be equal to http localhost on the port 5000. We are going to send over the address and the chain. This is going to return us a response. So the response is going to be equal to requests.get URL. The data is going to be equal to response.json, and we need to extract the value of that response, because as you can see here, the response gives us this native price, the exchange name, the exchange address, but what we actually want is the USD price over here. So let's go back to the project and say extract the price. So USD price is going to be equal to the data and get that USD price and return that price. And as easy as that, we are going to be able to connect through the code to the endpoint we already created on our Flask server. Now let's create that function to get the pair relation between two different assets. So check the pair relation. So for example, first we need to check the relation between Ethereum and Bitcoin, and then we need to check the relation between USD and Bitcoin. Let's say def check pair relation. Let's send an address 1, address 2, and the chain. The first price is going to be get token price using the first address. The second price is going to use the second address. And then we have to calculate the ratio of the prices, which is a simple division between the first price divided to the second price. Now we can return that ratio. So with this, we can compare the ratio between one address and another address, in this case, Ethereum and Bitcoin. And now we need another function to compare the relationship between radios. So def check radio relationship, which is going to take a current radio and a reference radio. Again, calculates the difference between the radios. The radio 1 is the token 1 divided to the token 3. And the radio 2 is the token 2 divided again to the token 3. So if the current radio is greater than the reference radio, it means that we are going to return false. And if the current radio is lower than the reference radio, we are going to return true. Remember how this works is if the current radio is overvalued relative to the reference radio, consider selling token 1 for token 3, and if the current radio is undervalued relative to the reference radio, consider buying the token 1 with the token 3. And as easy as that, we have our first strategy. So let's go back to the main.py and test this out. Let's remove this. First, we need to now again use that account. So account going to be equal to Binance Connect.getAccount. If the account we are using is capable of trading, so if can trade, then let's say print your account is ready to trade. And now we are going to use that calculate radio functionality. So calculate the current radio. So the reference radio is going to be equal to strategy dot check pair relation. And here we are going to send the first tokens. Don't forget to import the strategy at the beginning of the main file so we can access to that function. As we already have those pairs here on the settings, let's also add them. So here I'm going to say it going to be equal to project settings, tokens it. Bitcoin is going to be the same, but we are going to use Bitcoin Binance. So let's add a B. And USD is going to be exactly the same. So first we're going to check the relation between Ethereum and Bitcoin. This is going to be the reference radio. Now we need to calculate the current radio. So the current radio is going to be equal to strategy check pair relation between Binance USD and again Bitcoin. And once we have the relationships between these pairs, we can check the relation between radios. So calculate the differences between radios. And by the way, I'm going to just print reference radio and the current radio. So remember, this check radio relationship returns a boolean false or true. So I'm going to say here, check is going to be equal to strategy.check radio relation. And it seems I add an extra n here. Let's correct that. Okay. And we are going to send over the current radio, and the reference radio. So if the check is true, this is going to be a buying time. So buying, and if the check is false, it means that this is going to be a selling time. Let's save this, and so let's test this out. But remember, here on the Binance Connect, the actual function is called query account, not get account. So let's copy this, go back to the main, paste this query account, let's save. Also remember that we need to send over the chain we want to check for the change, which in this case is BSC, both for the reference radio and the current radio. Let's save this, and now we can test this out on the console. So let's run python main.py. Your account is ready to trade, and we now have the reference radio and the current radio, and as this is lower than this, well, we are on buying time. So we can add a new strategy over here. So we are ready to add the second part of our strategy over here. The next strategy is the candlestick increment or decrement. So depending on the trade type, buy or sell, we are going to check if the candlesticks had consecutively increased or decreased on a time step and set an order. So based on the radio strategy, if the relation says that we should sell, we are going to check if the last 3 candles has consecutively decreased, and if the answer is true, we are going to set a sell order. On the other hand, if the relationship tells us that we should buy, we are going to check again if the last 3 candlesticks had consecutively increased, and we are going to set a buy order. So let's do that. So as you already know, we already have this function get candlestick data. Using pandas data frames, we are going to be able to get that information using this get and transform data. So with that, we can create a new function to verify those 3 consecutive decreases or increases for the candlesticks. And we can create just one function for both. So let's say here on the strategy.py function to check the consecutive rise or decrease. So let's say here def determine trade event. This is going to take a symbol, time frame, a percentage change, and the candle color. Remember, when we get the information on get candlestick data, here we set up a red or green value, and if the open price is lower than the close price, the candle is going to be green and is going to be red otherwise. So inside of this function, we can say candlestick data is going to be equal to get and transform data, sending over the symbol, the time frame, and the number of candles is going to be 3. Now we have to check if those 3 candles have the same color. So review if candlestick data dot log 0 red or green is equal to the candle color, and the second one the same, and the third one the same. If this is true, it means that we have 3 consecutive decreases or 3 consecutive increments. So if this is true, we have to determine the percentage of change, because maybe the percentage changed between these candles is not significant for us to decide to create a new buy or sell order. So let's calculate those 3 changes. So here I have change 1 is going to be equal to determine percentage change between the open price and the close price. And for that, we need to create a new function called determine percentage change. So let's do that. Def determine percent change, this is going to receive a close previous and a close current. This function is going to return the close current minus the close previous divided to the close previous. And as you can see here, I'm doing that for each one of those candles. So if candle color equals to red, I'm going to print first drop equals to change 1, second drop to change 2, and third drop to change 3. Else, if the candle colors, if the candle color equal to green, I'm going to print the same, but instead I'm going to say first increase, second increase, and third increase. Now we need to compare the price changes against the stated percentage change. So I'm going to say if change 1 greater or equal than the percentage change, and the change 2 is also greater that percentage, and the change 3 is also greater or equal than that percentage. In that case, I'm going to say that we are going to return true, because this means that we can trade. And by the way, the percentage change we are sending over as parameter is the minimum threshold of increase or decrease we want to see in the price in order to make the sell or buy decision work. If this does not return true, so else we are going to return false, so we cannot trade. Also, after this if the three candlesticks are not the same color, well, we are going to also return false. And as easy as that, we have implemented the strategy to decide if we can or we cannot trade based on the information we are going to get from the three last candlesticks for a given token pair. Now remember that the query code asset list is going to get all the symbols based on a based asset and the ones which are available for trading, so we might add a new function to analyze all those symbols. On this demo, just for simplicity, we are going to just use, again, these three tokens. But as I want you to have this as a template for another projects, let's create that functionality on the strategy.py. Let's create that function then. So it's going to be called def analyze symbols. This function is going to take the symbol data frame. This information is going to come each time we execute this query quote asset list functionality, which is going to take all the exchange info. And as you know, this is going to take all the symbols from a base asset, but in this case, we are going to just use these ones. But as I want you to be able to use these with different amount of tokens, this analyze symbols is going to take the symbol data frame. And it's going to take the time frame, of course, the percentage, and the type. So first we need to iterate through all the symbols. For index in symbol data frame dot index, we need to analyze each symbol. So if the type is equal to buy, then we are going to create a new analysis. It's going to be equal to determine trade event, which we are going to send over the symbol data frame on the index, the time frame, the percentage, and of course the candle is going to be green because it's a buying order. If the analysis is true, remember the analysis is the function we just created. It means that if we have 3 consecutive candles and the increment or decrease on these candles are equal or superior to the percentage threshold, we are going to be able to trade. So if the analysis is true, I'm just going to print that the symbol has those 3 consecutive rises. Else, I'm going to print that the symbol does not have 3 consecutive rises. As this is meant to work for all the symbols, I'm going to sleep for 1 second and then use that time sleep 1. Of course, I want to return this analysis because based on the analysis, I'm going to put or not the buy or sell order. And the same is going to be for the selling. So I just need to put this inside of this if. And now I can put here if, else if. The type is sell. I'm going to do actually the exact same. I'm going to use the same analysis, but the color of the candle is going to be red. I'm going to print that if it has or not the consecutive drops. I'm going to wait 1 second and then return the analysis. And with that, we are ready to test this out. So I can return to the main.py, and here inside of each one of the types, both the buying time or the selling time, I can execute an analysis. But of course, I need to get first information of the pair I want to trade with. So for that, the asset list is going to be equal to that function. So Binance Connect dot query quote asset list. I want to take all the pairs related to Bitcoin because it was my reference token. Then, as I told you, I'm not going to use all the possible pairs for trade. I'm just going to use the pair ETH Bitcoin. So the ETH pair is going to be the asset list dot log the asset list on which the symbol is going to be equal to ETH Bitcoin pair. And of course, I want to get the symbol because I'm going to use that symbol later. So the symbol is going to be equal to the ETH pair, taking the symbol and its value. So with that, we can create a new analysis. So if I'm buying, I'm going to say here, analysis going to be equal to strategy dot analyze symbols, and I'm going to send over the ETH pair, which is going to be the data frame with all the information for that pair. The timestamp is going to be 1 hour. As this is a demo, I'm going to set up a really short threshold of increase for each candle, which is going to be 0.000000050 zeros. 1. And of course, this is going to be a buy order. If the analysis is true, or in this case, if analysis, I'm going to say print buying it. And of course, after that, I should put an order to actually execute the trade. We are going to do that later. And if not, if the analysis is false, I'm going to say that I'm not buying Ethereum because the analysis is false. And what happens when I'm selling? Well, it's going to be exactly the same. I'm going to create a new analysis, but instead of using buy, I'm going to use sell with the same generous threshold for the percentage drop using the same pair. And I'm going to say also, if I have an analysis, print that I'm selling it. And if not, print that I'm not selling, and the reason is because the analysis is false. So with that, we have now a correct analysis for each pair. Let's save this and let's test this out on the terminal. So Python main.py is going to again do the ratio comparison, and here we have the first increase, the second increase, and the third increase. This pair have 3 consecutive increases, so we can buy Ethereum. In this case, the only thing left for us is to actually execute that order. And on our code, on the Binance Connect, we have this function, make trade with params. So basically, we can do something like this. So I can go here. So if the analysis is true, I can say something like response equals to Binance Connect, make trade with params, send over the params and the project settings, and then like print out this response. But the question is, which ones are going to be these params? Here we have different approaches. For example, on the Binance Connect, I leave you these functions like place limit order, place stop loss order, place take profit order. So we can use different of these functions, but for now, let's create one on our strategy based on our needs. So I'm going to create a function which is going to give me these params I need based on the context. It's going to be selling for the selling part and buying for the buying part, of course. So I'm just going to copy this and paste it also here on the selling part. And now let's go to the strategies.py and create those functions, each for selling and buying. Let's start for the buying. So buying params function. This function is going to be called def calculate by params. It's going to take the symbol, the pair, and the time frame. First, we need to retrieve the candle data, and we want to just get the last candle. So raw data is going to be equal to Binance Connect to get candlestick data, and I'm going to send the symbol, the time frame, and I'm just going to request one candle. After that, we need to determine the precision. The precision is because each token pair has different amount of decimals. So I'm going to say the precision going to be equal to the pair I'm sending as parameter. Remember, the pair is going to be a pandas data frame, which inside of it should have a parameter called base asset precision. Also, we need to determine some filters. These filters are going to be used to also calculate the price on which we are going to enter, but using the correct amount of decimals. And the filters is going to be, again, using the pair, I look and get the filters. So I'm going to go through all those filters. For F in filters, I'm going to say if the filter type is equal to lot size, I'm going to create two new variables, which are going to be called step size, which is going to take the step size, and the mean quantity, which is also going to take the mean quantity. Else if the filter type is a price filter, I'm going to take its tick size. And you might be wondering, what are actually this step size, the minimum quantity, and the tick size? Well, I have two recommendations for you. First, please go to the Binance documentation and get the endpoint entrances, especially the ones when you are calling their API. But for example, look at this. If I get the information of one pair, in this case, just the information for the Ethereum Bitcoin pair, I'm going to have these filter types on which I have the price filter, on which I'm going to have the information on which is the minimum price I can start trading with, the max price I can trade with, the tick size, the filter, and which is the mean quantity, the max quantity, and the step size between the quantities I can trade. So with that information, I can make some calculations. So let's go back to the calculate by params. And first, I'm going to extract the close price. The close price is going to be from the candlestick. So calculate the close price. The close price is going to be equal to close price. The close price is going to be equal to the raw data and getting that close. So 0 close. And again, if you forgot where this close come, is because here on Binance Connect we have this function called get candlestick data, and we set up that the close tag for the close price is going to be the information which is going to come for each candle. And here on strategy.py we are requesting the last candle just to take this information. Now we need to make some calculations to make the Binance API happy with all the decimals and that stuff. So first we need to calculate the buy stop. We have the buy stop to have an increase of 1%. So the close price is the latest price of the last candle, and we want the candle to increase 1%. Now we need to round the buy stop price to the nearest valid tick size. So buy stop is going to be round buy stop divided to the tick size by the tick size. So first we round this information and then we multiply that for the tick size. Now we need to calculate the quantity, and the quantity is going to be a base quantity. In this case, I'm going to basically trade 0.1 Ethereum divided by the buy stop, and then we need to round that. So I'm going to say that round information is going to be equal to the quantity. Take the max between the mean quantity and the round information between the raw quantity minus the right quantity module the step size and the precision. This is just some base math, again, to make the Binance API happy with all the decimals we need to use. So the params are going to be equal to a dictionary on which the symbol is going to be equal to symbol, the size is going to be, of course, buy, the type is going to be stop loss limit, the time in force is going to be GTC, the quantity is going to be the quantity we just calculated based on this mean quantity, the step size, and the tick size. The price is going to be equal to the buy stop price, and the trailing delta is going to be equal to 100. And as this is that, we have all the params we need for the buying order. So let's return these params. And what happens for the selling part? Well, it's going to be kind of the same. So I'm going to create that function right now and explain it to you. So here we have the selling function. The difference is that instead of we expecting the price to increase 1%, we are expecting the price to decrease 1%. And also, of course, the site is going to be sell. The rest is actually almost the same. I'm going to save this, and now we are ready to use that. So I can return to my main.py, and here I can say the params is going to be equal to the strategy dot calculate boy params. Let's send the symbol. In this case, is going to be the symbol I already have here. So the symbol, I need to send over the pair, which in this case is the Ethereum pair. And no, here is not the account, but instead the time frame, which is going to be again candles of 1 hour. And the same is going to be for the selling time. So the params going to be equal to strategy.calculate sell params and sending over the same information. And this is it. This is all we need to start executing trades in our name. So let's test this out on the console with Python main.py. This is going to, again, go through the basic analysis of the radio, calculate the increases of each candle. It seems that we can trade, we can get the close price, and we are going to make the trade with params. And as you can see here, we have an order ID. It means that we successfully executed a new trade. And the same is going to be true if the analysis or the relation between the two pairs ask us to sell our tokens. In that case, this selling time is going to be executed. With that, we already have the part 2 completed. We created a first skeleton with a lot of functions to interact with Binance. Secondly, we created a simple strategy using different indicators and Moralis endpoints. And now we are ready to go to the last part of this blueprint, which of course is to automate the trading process. Basically, we are going to let our bot to work for us while we are sleeping. How it works? Well, we are going to use Moralis streams to listen to transactions made by whales or traders you trust and execute your analysis automatically each time they make a move. So if they buy or sell tokens, Moralis streams is going to automatically send that information to our application, and then we can execute all our analysis and let the bot to trade for us. So let's get started with this part. For this step, please go to your Moralis stream panel and let's create a new stream. We have a lot of templates here, but the one we want is this whenever a wallet receives or sends assets. This is important because this wallet address is going to act as the whale. As this is a demo, I'm going to use my own wallet address, which I'm going to copy and paste over here. Let's click on next. This is how this is going to work. If the sender of the transaction is this account, it means that the account is sending Ethereum to another one. In this case, this will simulate the account is selling their assets. On the other hand, if the receiver account is the wallet address, it could mean that the wallet is receiving assets, so that means that the wallet is buoying. So we are going to use that logic. Remember that this is a demo and you can add here actually real whales that you know. And also remember that Moralis streams on the pro version allows you to listen to simultaneous address at once. So for now, let's keep this as on the demo. Let's select the Cephalian network, which is the one I want to use. You can select any other network. If you want to take this bot to live, to production, you might select the BSC network. Then we don't need any contract interactions, and actually this is it. We don't need anything else here. So let's configure the webhook URL. Moralis is going to retrieve the information from the blockchain and is going to try to send that information somewhere. For that, we need to have a bridge between our local server and the internet. And for that, we need to create a webhook. So for that, I'm going to return to my project on the app.py and let's create a new route. This is going to be a route called webhook with the method post. Let's define the webhook method and let's add some functionalities. First of all, let's decode the data, which is going to come from Moralis using the UFT8 standard. Then let's create a JSON object with that information. Now we need to get the information of the transactions. So transactions is going to be equal to the JSON object and the transactions inside of that JSON, TXS. So for each transaction in the transactions, please take the from address and the to address, and then let's make some comparison. In this case, the whale is going to be, again, my account. So whale equals my wallet address. Let's put this into lowercase. So whale equals whale.lower. Now, if the from address is equal to the whale, it means we need to sell. If the to address is the whale, it means that we need to buy. And if we get a non-response, let's put an else statement here and just import no whale. Also, as this is a root, let's just return. Okay, so something interesting is going to happen here. So with that, we have the entry point on our server to connect to the Moralis streams. So for that, we can go to our terminal, create a new webhook URL using ngrok. So ngrok on the same port we are running our server. This is going to give us a public URL. We can copy, go back to Moralis, paste the webhook URL here, put the endpoint, which is webhook, and set up a name. For example, the Binance bot, and the tag is going to be BSC bot. Let's update the stream. This went successfully. Let's change this to production. This is going to connect to our local server through this bridge. Now this is done. So we can execute the analysis based on if we need to sell or if we need to buy. So I made some changes to the main.py. Instead of keeping the main.py, I changed it to execute.py. And now the main function is transformed to another function called execute analysis and trade. And this is going to take the parameter buy or sell. Then when we check using the check radio and relation, we are going to also check that they are on the same page. So if check is true, we are going to verify if buy or sell is into buy. And if the check is false, we are going to verify that buy or sell is on sale. So at the end, we are going to have something like this. Here we have our server running, so I can go back to my browser, open MetaMask, change the account. Again, this is just for demo. In the real case, the account transferring the assets should be the actual exchange, but this is just for showcasing. Let's click on send between my accounts, send this to the account number 2, put the amount. I'm going to put a random amount. Let's click on next and let's click on confirm. Let's go back to the terminal and this should work. It's stating that we should buy, but we already know that. What's left for us? Well, take this function I've just told you, execute analysis and trade, and actually use it on the app.py. So let's import the execute function, and then instead of just printing, let's use it. So instead of just printing sell, let's use that execute analysis and trade, send in the parameter sell, and the same is going to be for buying. So let's save this. This should reload our application. So now we can make the demo again. Let's send, transfer between my accounts to the account 2, send a random value. Let's click on next, confirm, and we can return here to the console and wait. And as you can see here, this works properly. This is making the request to the other endpoint on our server called get price. We do that 4 times here. Then we start executing the analysis we already know with the reference radio, with the current radio. This determines that we should buy. We start looking for the increases, but as you can see here, the third candle has not an increase, so the buying process is not executing. And this is it. From now on, we can keep this server running, and each time the whale makes a movement, like happened just now, well, this is going to execute our analysis and make the trades for us. And also remember that this is a demo and I didn't set up the value here when I'm getting the information from the transaction, because you might just execute this if the value is greater than certain amount you select. But that was it. With that, we finished our Binance bot with the 3 steps: creating the basic functionality, creating a trading strategy, and we automate the trading process. I hope you enjoyed this blueprint so far, and I'll see you on the next occasion. See ya!